In this session, we're going to explore the installation of the connecting rod caps on the Detroit Diesel 8V92 TTA marine engine from a deeper, more advanced mechanical perspective. This step is more than simply bolting parts together. It's a controlled precision procedure that directly influences the engine's structural integrity, lubrication dynamics, and long-term operational stability. Before any installation begins, the connecting rods undergo a visual and dimensional inspection. The big end bore must fall within Detroit Diesel tolerance limits, and the parting surfaces must show no distortion, fretting, or uneven wear. The mating surfaces between the rod and the cap are machined to lock together with exact precision. Even a microscopic burr or dent can shift the alignment and compromise the oil wedge that forms during operation. Another critical step involves checking the rod bolt threads and the female threads inside the rod. These surfaces must be perfectly clean and free of oil contamination, corrosion, or debris. Any resistance when threading by hand is a sign of galling or thread deformation, which must be corrected before torque is applied. Rod bolts are highly engineered components. They are designed to stretch within a controlled elastic zone, storing clamping force that maintains bearing crush under heavy load. Once the piston and rod assembly has been lowered into the cylinder bore and positioned on the crankshaft journal, the connecting rod cap is installed. The cap must slide on with a natural fit, never forced. If the cap needs pressure to seat, the rod may be twisted or the bearing shell improperly installed. Proper geometry is essential to forming the hydrodynamic oil film that supports the crankshaft under power. The bearing shells used in the 8V92 TTA are tri-metal or bi-metal designs depending on the overhaul spec, and they serve as a sacrificial surface that protects the crankshaft. When installed, the bearing tangs must sit perfectly in their locating slots. The cap should clamp the bearing evenly, producing what is known as bearing crush. This crush prevents the bearing shell from spinning inside the rod during operation. If crush is inadequate, the engine will fail, and it will fail fast. Now comes the torquing procedure. Detroit Diesel requires tightening the rod bolts in sequential steps to allow the bearing to settle naturally around the journal. Each bolt is tightened gradually, using calibrated tools, until the specified torque value or stretch measurement is reached. This staged method ensures uniform pressure across the journal and prevents distortion. Uneven torque can create hot spots on the bearing surface and interrupt the oil film, leading to metal-to-metal contact. After torquing is complete, crankshaft rotation is checked by hand. This is a critical diagnostic moment. Smooth rotation indicates proper bearing alignment and lubrication clearance. If the crankshaft feels tight, asymmetric, or notchy, it signals an issue such as improper cap orientation, debris under a bearing, or insufficient oil clearance. No further assembly should continue until this is corrected. To ensure long-term reliability, builders often check rod side clearance, bearing oil clearance with plastigauge, and end play of the crankshaft. These measurements confirm that the rotating assembly operates within the required tolerances for thermal expansion and lubrication flow. Once all connecting